Look at a tide chart. 2 high tides every day, 2 low tides every day. Now here's the strange part. The moon only pulls on Earth from one direction. So why does the ocean bulge on both sides of the planet? The side facing the moon and the side facing away from it. This is one of the cleanest counterintuitive results in physics. And the answer rewires what gravity even is. Most explanations stop at the moon's gravity pulls the water up. But that cannot be the whole story. The moon's gravitational pull on your body, right now, is about 1/10,000,000th of the Earth's. You do not feel it all. The moon does not lift the ocean any more than it lifts you. So what actually creates a 1-meter bulge of water? The real answer is not gravity. It is the gradient of gravity. Gravity gets weaker with distance. So the moon pulls the near side of Earth slightly harder than it pulls Earth's center, and it pulls the far side slightly weaker than the center. Now sit in the frame of Earth's center. From here, the near side ocean is being yanked away from Earth toward the moon, and the far side ocean is being pulled less than Earth itself. So Earth is being yanked out from under it. Same result on both sides. The ocean lifts away from Earth. 2 bulges. The math is simple. Newton says force equals G times m divided by r squared. The tidal force is what is left over after you subtract the pull on Earth's center. Take the derivative. Tidal force scales like 2gm over r cubed times the size of the object. So tides fall off as 1 over distance cubed, not squared. That makes them brutal up close, negligible far away. For the moon and Earth, the tidal acceleration is about 1/10,000,000th of ag, microscopic per molecule. But the ocean is a sextillion kilograms of water. Pile up that microscopic force over half a planet, and you get meters of bulge. Now the spinning. Earth rotates once every 24 hours, but the moon is also moving in its orbit, so the bulges drift along too. The net effect. Every 24 hours and 50 minutes, a point on Earth's surface passes under one bulge, then the other, then back again. 2 passes, 2 high tides, 2 low tides. That extra 50 minutes is why high tide drifts later each day. It is the moon telling the ocean, I have moved. The sun does this too. It is 27 million times more massive than the moon, but 400 times farther away. And tides scale like 1 over distance cubed. Plug it in. The sun's tide is roughly half the moon's. When sun and moon align, at new moon and full moon, the bulges add. Spring tides, the highest ones. When they pull at right angles, at the quarter moons, the bulges partly cancel. Neap tides, the lowest. The same equation explains another extreme. Near a black hole, the gradient of gravity gets so steep that the pull on your feet differs from the pull on your head by thousands of G. Your body is stretched into a noodle. Astrophysicists named it spaghettification. Tides, all the way down. The lesson is that gravity is not a single number at a point. It is a field, and what fields do to extended objects is stretch them. Tides are gravity's signature on anything bigger than 0. Same equation, sextillion kilograms of seawater or 1 human falling into a black hole. The ocean has 2 high tides a day for the same reason a falling astronaut becomes a noodle. The universe pulls harder on one end of you than the other. If this surprised you, hit like and subscribe. Counterintuitive science every week.